Hello guys, my name is Sérgio Santos Silva Filho and my advisor is Professor Rodrigo Bonacin. I am here to present best practices in WebQuest design, stimulating the higher level of Bloom taxonomy. Summary, introduction, concepts and theoretical foundations, background on WebQuest, modern best practices through norms and rubrics, empirical study and analysis of the results, and the final remarks and future works. Introduction. WebQuest is a model to structure and promoting this method and format for stimulating student learning using web results. According to Dodge, WebQuest is an inquiry-oriented lesson form in which most or all the information that learned works with come from the web. Typically, WebQuests are designed by teachers to be used in classroom. They include the question and pre-select resource to be studied by learning during the guided lesson. Does this work investigate a method and tool for construction WebQuest to stimulate learners at the higher levels of the Bloom taxonomy? Our method is based on collaborative construction and adoption of best practices. We based our method in the following theoretical foundations: Bloom taxonomy, that provides the learned cognitive levels and objectives, semiotic and norms that determine expected patterns of behaviors, to the followed to achieve the learning objectives, rubrics for WebQuest evaluation. According to this approach, we constructed a prototype named MSEAWQ. Our methods support the design of WebQuest following the best practices as well as definition of new ones. In the next chapter, Concepts and Theoretical Foundations, the Bloom taxonomy constitutes a classification system of educational objectives in 6 levels of cognitive domain. The first level is remember or knowledge. The learner is able to remember previous information and content. The second level is understand or comprehension. The learner is able to understand previous information and content. The next level is apply or application. The learner is able to apply previous information and content. The next level is analyze or analysis. The learner is able to analyze previous information and content. The next level is evaluate or evaluation. The learner is able to evaluate previous information and content. And finally, create or synthesis. The learner is able to create from previous information and content. Theoretical foundations of organizational semiotics and norms. The measure, methods for eliciting, analyzing, and specifying user requirements is a set of methods from organizational semiotics with user norm as a central concept. Our study used the norm analysis method NUM, one of the major methods to elicit and model an initial set of best practices in the design of WebQuest. The NUM included a set of steps to elicit and model norms, responsibility analysis, proto-norm analysis, trigger analysis, detailed norm specification. Norm can be behavioral, perceptual, cognitive, evaluative, or denotative. In the next chapter, background on WebQuest. web requests as well following structure. The introduction section presents the theme and activity to be performed. The text section describes results of what is expected from the activities. The process sections describe a sequence of steps to accomplish the tasks. The evaluation sections presents how the learners will be evaluated. The conclusion section summarizes that will be learned by completing the lesson, and the credit lesson lists the results and the reference, including acknowledgments optional. Studies, for instance, evaluated 483 Portuguese language web requests and point out that only 41% of them can be considered true web requests, while 59% were classified as exercise sheets in the web request format. In the next chapter, modeling best practices through norms and rubrics, a method to model best practices using norm. The norm is started by using the web requests sections as a structure, that is, the best practices are grouped and analyzed according to each section. For each section, we identify norms for the design of content that stimulates each level of the Bloom taxonomy. The web request rubrics are also considered at each section during the best practice elicitation. Initial analyzing the next web request sections to model or create a new best practice. First, we choose the web request sections, and then we decide whether to analyze using Bloom taxonomy or rubric analysis. None will be executed, and the author will describe the best practice and give an example. Repeat the process to create a new best practice for the same sections. One done created the best practice for all the sections, terminate the modeling process. Num, the norm analysis method begin. Here each the responsibility analysis define who will do what, and then the protonorm analysis define who can do it. Trigger analysis define when can they do it, and finally detailed norm specification where to author describes formally or informally that is to be done. This is a norm structure. Whenever a condition happens, checking the states, then accordingly the agent or professor is obligatory, permitted, or prohibited to do an action. This is operator deontic. The MSEAWQ prototype. The objective of the MSEAWQ is to support the educator design through web requests. Our method has a set of features to include manage and publish web requests. Our method includes a set of previously defined best practices. The prototype also provides the option of including new best practices. You can find best prototype in this address. This screen to create a new best practice according to sections of a web request. To create a new best practice, we need to first give it a name and description and example. And here too we decide we can see Bloom taxonomy to help the professor create the best practice. In this example, the user is editing the text sections, the system provides an editor and a list of best practices. The user can visualize the details and examples of use of each best practice and then choose between use or ignore each practice according to their judgments. And in this screen we create a new web request. First, we give it a title, abstract, and the create of the class. And then, according to the web request sections, the author chooses the best practice they will use it or ignore it. And if they click on each, they can see a description and example. And finally, they detail the sections in editor. In the next chapter, empirical study and analysis of the results. The objective of the study is to analyze the potential of the use of the best practice suggestion in the content of MSEAWQ. The study is performed by 3 primary elementary schools teachers who had previous experience with WebQuest design. The first teacher designed WebQuest about study editing rewrite. The second teacher designed WebQuest about geometric shapes. The third designed WebQuest about introduction to algebra. All the study declared that they had previous experience with computing and the internet. The study is performed according to the following steps. Each teacher designed 2 WebQuests for the same topics, one with and the other without the best practice of our method. Each teacher elaborates an evaluation from after the WebQuest and evaluation from containing at least one question for each level of the Bloom taxonomy. Each group is randomly divided into 2 subgroups, WebQuest 1 and WebQuest 2. WebQuest 1 uses WebQuest design with the MSEAWQ, while WebQuest 1 used ones without. The teacher administered the WebQuest sections for both subgroups simultaneously and separately. The teachers applied the evaluation from attributing and text score from 0 to 10. Test scored after the WebQuest sections. In this table, we can see the evaluation results of the student of the 3 subgroups and the average of each subgroups. We can notice that the average of the groups show worked with WebQuest 1 are always less than those of WebQuest 2. Table 2 presents statistical measures of variance, degree of freedom, T and P bilateral, calculated from Table 1. When we adopt level of significance 1%, we concluded that the introduction of the MSEAWQ resulted in insignificant improvement of the text scored considering the study population. Statistical results, and here we see the statistical results. We notice that the values of P bilateral are always less than 0.01. In the final chapter, final remarks and future works, various studies about WebQuest show positive impact of using this model on web-based lesson. In this paper, we present a normal-oriented method and the MSEAWQ prototype for suggesting best practices in the design of web quests towards the higher cognitive level of blue taxonomy. The groups of students that perform lessons using web quest design with MSEAWQ obtain higher test scores as compared to the control groups. However, this study is limited in terms of the scope and size, in that it tests only 3 lessons with a restricted group of students. Despite the positive results, the study is based on an initial set of just 12 best practices constructed using NUM. This set should be collaboratively expanded by educators using MSEAWQ. A large study with other disciplines in lesson is under development. Acknowledgements for Faculty Campo Limpo Paulista and Mato Grosso State University. This work is partially funded by CAPES. The author also thanks Maria Auxiliadora and José Inácio Fraga schools, Ricardo José de Araújo and Anderson Francisco de Oliveira for the valuable contribution on prototype development, and thank my student Bassan, who was my English teacher for this presentation. This is my email for contact, santos@unemat.br. My name is Sérgio Santos Silva Filho. Thank you very much.